Good evening, everyone. Welcome to this PIANC event on wharf construction, from restoring old to building new. We gather across the country in Auckland, Wellington, and online, and it's great to see so many of you here. The event is about more than just listening. It's about being part of a community focused on innovation, sustainability, smart preservation of our built environment. As we dive into the practical aspects of wharf construction, let's remember every step we take, every idea we share, and every challenge we tackle, it's crucial. It's not just about the end result, it's about the process, the collaboration between us all, the collective effort it makes to build our cities, ports, and harbours, to make them better places to live and work. So a big thank you to our sponsors. Tonight we're here in WSP offices, we've got Auckland and the Becker offices, and we've got Brian Perry Civil here sponsoring this evening. And thanks for making this event possible. Your support is invaluable, and thanks to you, we can share knowledge and foster innovation. And to all the volunteers that made tonight possible, your contributions are what makes this event a success. And they help us all feel And they help us all feel a part of something that's bigger. And a special thanks to the New Zealand PIANC community. I see Tom's here tonight. Thanks for not giving up on the dream of having a thriving ports and marine community. We so nearly lost all of PIANC New Zealand, so thank you all. And it's been a great success since we took the realm. And thanks for bearing with us all as we learn to take this ship where it's going. So the PIANC background is established in 1885, I'm sure you'll remember. It's the leading knowledge partner for governments and the private sector in the design and development and maintenance of ports, waterways, and coastal areas. And at the core of PIANC's mission is the publication of technical reports produced by international working groups of expert participants from multiple member countries. Through our conferences and events, we bring people together in the ports and maritime communities for the knowledge and sharing and networking. That's what it's about. Tonight, you will see the leads of the New Zealand Chair chapter, who will give further information on what I've just explained. So let's get down to business. We're here to learn and share and contribute. Let's make the most of the opportunity and grow to be a part of the legacy of our ports and maritime communities. So now for tonight's first topic, we'll learn all about Napier's Wharf 6. So please welcome Luke from Heb Construction.
Standing here today, not only are we opening around 6 months ahead of schedule and on budget, but we're also commissioning one of the country's largest pieces of privately funded transport infrastructure in over a decade.
A strong port is important to our region's economic prosperity. Te Whiti is a crucial part of Napier Port's future direction, strengthening the port's operational agility and resilience and delivering capacity to support future growth.
This success has been a group effort, largely achieved because we prioritise relationships, building trust, and doing what we said we would do. We chose partners with similar values to ours, including commitments to quality, safety, and the environment. The starting point was surrounding ourselves with the best people, the best contractors, the best designers, and the best team on the ground.
It is absolutely my privilege to stand here today before you all with my team and officially declare 6 Wharf, or Te Whiti, open for business.
Great, so we got there. Nothing like a promo video to get us kicked off. Thanks to the Napier Port team and Chip for letting us use the video. I've ran through. Yeah, my name's Luke Tomlin and was a project engineer for the revetment on the Napier 6 Wharf project. I'm going to talk you through some of the work streams we had there, but heavily focused towards the revetment. Also got quite a few PowerPoint slides to get through, so towards the end I might just have to flip through a few if we're losing time. To keep on track, so without further ado, we'll get into the plan there. So talk through those work streams, onto another promo video, and then into some questions if you guys have some. So starting off with some historic photos of the Napier Wharf there. Napier has been welcoming ships to the central New Zealand since 1855. The original port was in Aotearoa, which is 600 metres to the west. A public poll in 1885 resulted in the port being moved to its current location, and then following the earthquake, the old Aotearoa became virtually unusable. In 1886, the breakwater was first installed. This one here, and the wharf's constructed. This is later on, years down the track, breakwater extended and reclaim going on. Project conception and timeline. Why was a new wharf needed? There's several reasons, but the primary reason was shipping congestion. Shipping congestion arose when ships longer than 250 metres were moored at number 5 here, and let's look out further, rendering wharfs 1 and 2 unusable during those periods. And that was costing the Napier Port significant money, so they looked into an option to design a new wharf, design and construct a new wharf. Moving into the timeline of the project, 2006 it kicked off with optioneering on locations for a new wharf. They searched around, and from 2006 to 2015 they looked in this area here, but that came unstuck with resource consent because it was going to be affecting the beach and fishing and diving. So then 2016 to 17, the new wharf was planned to be put out here, and Becca engaged, I'm sure there's Becca people out there, to do some design work on waves, erosion, sediment control. And then we moved into 2018 to 19. ECI was progressed. He'd made it through and was awarded. Work started late 2019, and the first ship came alongside in July 22, 6 months ahead of schedule. Project overview. Here's some stats for you on the works. Dredging, there's 3 million cubic meters of material needed to be dug out from the approach channel and the turning basin. There's also an artificial reef constructed using existing limestone revetment. The revetment itself, the new one, transporting 50,000 tonnes of basalt from a whangarei quarry down the coast, delivered to site, and then that was used to place the first layer of armour, and then the second layer consisted of 4,500 concrete blocks, which were cast on site. These ranged from about 5 tonne up to 18 tonne. On the piling front, there was 400 piles. They ranged from 900 to 1200s, and up to depths of 45 metres. The wharf deck was 390 metres long, 34, 35 metres wide and around a metre thick. There's a bunch of fender panels, bollards and more masters to be put in on the front side. And then some groundworks on the land side. So you can see through the photo the new wharf and the landside wharf works going about 60 metres inland. To the construction process, piling. So the piling was five grid lines. The first two was completed from the first two, AB was one stage and then CDE was another stage. The landside piles, for the first half of it, we could complete with a gate shown in that first photo, and then the second ones, the grid lines came inland and we're able to complete those just with the land-based gate, which sped up the production quite a bit. We move on to the second stage, which is the CDE gate. At this point in time of the project, there was HEB's biggest piling gate, and it would cantilever off the first two rows of piles. And then we would put a couple of temporary piles in at the far end. Then it would be balanced off that and we'd install the permanent piles. You load that in the brake. That's this one here. Yeah, so that's a C shot showing the soil mech out on the piling gate. You've got the temporary piles in there supporting the gate and construction of the permanent piles. On the right hand side, you've got the cage reinforcing for one of the longer piles getting lowered into the pile. We had a few issues on the piling front, and I'll talk through two of those, rocks and gas. Large rocks were found left over from an old revetment. Hitting these large rocks resulted in crushed casings. Therefore, we required to probe the piles installation by welding on some shoes and breaking up the rocks before the permanent casings were put in. This slowed down the start of our works, but it lasted for 40 or 50 metres, and then we could go back to just normal piling once we got off the alignment of the old revetment. Gas. During the piling process, sort of halfway down the wharf, the team were installing a pile and they'd reached the correct embedment. They proceeded to cut the top of the casing off and flame went up the top, and lucky the guys down off the side cutting it. There was no injury, but close call for us, some lessons learned. And what was actually happening, the guys worked out that, yeah, would hit some natural gas and it's bubbling up through the pile, and in the empty pile, the empty casing over a day or so, it built up that much that it just... so we had some learnings out of that. The guys had some gas monitors, and we safely carried out the rest of the works with that in mind. With the little oil rig here, the little lighter side was the pilot thought they'd cracked it, they'd got into some money, but when they did the calcs of how much was going to come out of one pile, they needed about 10 piles hooked up together to run one gas bottle, so came pretty unstuck. That's the piling. Onto the revetment. So I'll talk a bit further about this one. This was my section of works. So you can see that there, the typical cross section, and then the plan view down the bottom. So I believe Becca designed the revetment in a simulation pool in Australia, and that was done in the ECI stage. So when we turned up on site, design was complete. You've got an underlay of rock sitting on some bitumen, and then you've got a series of blocks on top, nicely stacked together there. The different colours refer to different dimensional blocks. Sorry, so whole range of them. I talked about the rock getting barged down from Whangarei. So there was 16 loads with rock barged down. That last barge load, we had to be pretty calculated to make sure we had enough and didn't run out and have to order an expensive balance load. Also in that photo on the right hand side, you can see our precast yard where we had around 20 to 25 moulds, and we'd pour those blocks there and then store them on site. You can see some down to the bottom right hand side that I'm laid over them. Won't talk too much about it, but we placed cloth with this gadget out here that would release the cloth over the piles, and then when we're outside of the pile line, we held it together with some reinforcing to make sure we got the overlap required. The rock placing we did with a rock bin, we'd split it up into different zones, different bins, and the operator would place a nominated layer over the whole revetment. Then we'll move on to the next one. We were lucky enough that Herons was doing the capital dredge in the harbour, so they had a multi-beam survey, which helped out with our rock placement. So what you're looking at there, the top left, is the first rock survey. Then we would overlay the rock design, which is the one on the right hand side, top right, the grey surface, and you can see the rocks popping through it. And then the bottom image is a cut and fill map, so blues low, reds high, and whites within tolerance. So then we would take that cut and fill map like that, overlay where we needed to top the bins up, and we're able to quite accurately do top ups, so minimal grading and reworks once we had a digger out there. So that's the rock onto the armour blocks. So we originally started with 7 types of blocks. So this is the design when we turned up, and we needed to work out how we're going to place these blocks and how it's all going to work. So the first bit of work we did was a trial with the blocks there to work out in the quarry in Whangarei how they would stack up. And we quite quickly realised with Becca there that we needed some tolerance built in, otherwise the blocks would end up on the top of the crest in no time, just with no play. So we put a 50mm chamfer on the blocks, so they would come down, and that allowed the blocks to take up that tolerance for when they were on rocks and not on a completely flat surface. Then we moved on to working out how we're going to place it. We had a few different options that we looked at, using the crane, using grapples, using grabs. We decided that we needed a fixed grab to be able to physically force these blocks into place, and just releasing them with a crane and one of these other contraptions wouldn't give us what we needed. So we selected a long reach digger, and we're lucky that within Heb we had 120 tonne that we could utilise. Once we knew the machine we could place these blocks with, we looked into what attachment we needed on the end. We knew that we needed a tilt and rotation, so we selected a 360-degree grab. There was none on the market, so we needed to go out to some companies and do a design with them. So we ended up with a South Korean, sorry. South Korean. You guys are still alive, that's good. South Korean company, and we worked with them over a few months to bring something together. The tilt rotator, we were lucky that there was a one already out there large enough. So now we knew how we wanted to place them. So the next things we looked at is how we grab these blocks. So we proposed a recess into the block so we could actually physically grab it, and we'd be grabbing the blocks from the same position each time. And that would give us some certainty around placing them. And with that, we realised that the blocks above the piles needed special inclined recesses so that the grab could actually place them. See the clash there. And then also the blocks didn't have a design tolerance built in for the piles. So we were able to show that we needed some tolerance there. So we worked on some bird's nests, we call them, to take up those. So our 7 blocks grew to 15 different types there. So we had to keep track of all of this while we're precasting and knowing where the different blocks needed to go to. It's just a 3D image of the grab we signed up. I won't talk too much about it, but there's quite a bit went into the actual surveying, installation of a sensor into the grab, not something custom, so we had to work through that. And this is what it looked like once we got all the design over the line. Is we used about a 50-ton gate there to walk the long reach out onto, and we would place blocks out the western side of the gate, and we would just keep leapfrogging down, following that leading edge, and then also place the top ones from shore. So we would work down the wharf that way, and then there's about 100 metres at the western end of the wharf that of revetment to construct, but no piles. So we used an outfit from Picton, some of you guys might know him, Bo, from Nautilus, and we had our 120 on the barge, and we were ferrying blocks onto it. You can see one up the top end there, landing on the barge and placing it. Quite a few tricks around placing blocks off a barge there, which we learnt. So some of you might be asking how the operator knew what he was seeing. Placing some of these blocks, well, the toe was down 14 metres and no vis. So we had a system called Trimble Marine Control in the cab, and he's pretty much playing a computer game. So, but we had to work with Trimble to come up with this too. So I'll just push play on this. So this is the operator placing a block. So he's reaching down. It's got a few different views there, but he's basically putting the green block within the red block. The tilt, he's got the rotation. So it wasn't any old operator that could do this. We needed a young guy with some skills. We started with we had quite a few, to be fair, but yeah, we ended up with a guy that does 95% of them. I'll just run. It was, yeah, we needed to create our own 3D model. We were just working off the 2D drawings. So this gave us good insight of what we needed to do, and constraints around piles and diggers, and also presenting it to the guys and showing them where to sit and how to place it. Another tool we had was we scale model and placed a whole bunch of rock on there, and I'll just skip through this, but it was another good tool to show the guys on the ground what we're trying to do, and troubleshooting with them and Becca and so for the wharf construction, we had these steel molds that would sit in between each vent on those ears, welded to the side of the piles. We would pour 2 vents at a time, about 11 meters wide, and then we would strip the forms out the seaward side using a winch system. So you can see that on the right hand side there. It's another view of, this is the first concrete pour happening. So it was a big push to get that through before December, before the end of the year. I think it was 2020. So the guys managed to do that, which was good. That's another view there. So the crane would walk on the previously poured concrete once it had hit a certain MPa, and the reinforcing was landward side, and he would just operate from there and then pull the forms out. We were getting 8-day turnarounds for a pour, and there was about 30 pours total to be done. Moving on. So I threw this one in here. I couldn't not share the crew we had there. We had a whole bunch of good people and quite quirky people as well, and it just sort of brought out the best in everyone. That's our, down the bottom there, that's our construction manager. Some of you will know him, Nick, beating up our supervisor at a Christmas do. This guy up in the top right was called Boots. He was fairly quirky. He had pink hair and a set of tits to go with it. Just all added to it, and it was a good environment. Bottom right, we were lucky enough last year to take out the contractors award for over 100 mil. And I would also mention before I play this, another key part of it for us was the integration we had with the Napier Port and Becca, close working environment. Lots of barbecues on Fridays and things like that. That was key to the success of the job. Questions? Sorry, I probably went a bit over, but
That was good, man. Real good. There are a few on the chat.
Yeah, there's one that's just
Generate the straight out.
Yeah.
You're right.
yeah. Cool. That one come up on your end. Yes, you know. Your chat then. Yeah, here we go. If you want to lay that out.
Would you choose to do the block revetment like that again? Were other alternatives considered and ruled out? First time I saw the design, I thought, yeah, anything but this. And the reason for the design, I'm sure most people know, but the blocks were much more efficient and required less rock to be shipped down. So significant savings for the port and for, I guess, everyone. But we just needed to work through that methodology. It definitely worked, and there's many a times that we're fixing the GPS of the digger and many issues down the track, but we did get there, and I guess, yeah, I would do it again like that. But first choice would be just rock if that was the option.
Any more online? Or?
Did the design have structural joints in the deck? Yeah, there was one structural joint halfway down, expansion joint. So split up, yeah, 200 meter lengths. Great, I think that's it.
Here in the room, or
It's just interesting how, you know, the berth that was it the 250 meter vessels were using that was sitting out proud from the structure. How short was it? What was the overhang?
Yeah, I did catch up with Chip yesterday around it. I went away and finished my presentation, thinking I'm not quite sure what that was, but the restraint was 250 meters in there. There couldn't be one and two. So yeah, unless Chip, are you online?
Yeah, I was going to ask that question because I wanted to ask how your moormaster's going.
Chip Holland has put his hand up. How do we?
Natasha, you might have to use them if that's possible, please.
And Nat, if you could
Yeah, just 2 seconds, just doing it.
I'll go back to
There
that.
you go.
I'll take you back to that one.
perfect. That was just mine. I want to throw you right under the bus if Chip.
No, Chip, throw Chip under the bus.
Yeah, sounds good.
Right.
So the question, just for anyone who didn't hear, is just how the moormaster's going. With I understand you have quite a tricky wave frequency out there.
Yeah, so I guess the first question around the 250 meter maneuver harbour. So see berth 5 there on the screen there. So we have vessels up to 294 in length, but we had a restriction that anything over 250 meters required us to remove the vessels off berth 1 and berth 2 when we were trying to bring that vessel off 5 Wharf, so a main container wharf. Those vessels had to go out first, and then would move the vessel into 5 or out of 5, and then would bring them back into 1 or 2. So the additional moves required from our marine team and the shipping lines was significant. So the initial basis of the business case was to get those larger vessels outside that inner harbour area. So now we bring the vessels past the vessels on 6, with 6 being our number 1 container berth.
Cool. Do that. Yeah. Thank you. And then on to the moormaster question.
Moormaster. So we've definitely had our challenges bringing a new piece of technology into a space that I guess we're probably not all as experienced as we expected with that. But I mean, as with anything new, it's taken a phase, probably about 12 months for us to get into a position where we're getting great utilisation out of that berth. So we've had our challenges, but we've pushed through it, and we're coming out the tail end of it now. So we've had quite a great season on that berth for the last 6 months or so. So yeah, yep.
Cool. Cheers, Chip. I've got another question here. What was the rock layer you drove the steel piles? So the rock layer was, this is all, if I go back to it. Oh no, it's already there. So that view there, that's all reclaim, where the containers are. And at some point in time, where the piles were, was the large rocks had been dumped out. And correct me if I'm wrong, Chip, but I'm pretty sure they came from Bluff Hill, limestone, dug out of there and dropped straight in as part of the reclaim.
Yeah. So the problem with Hawke's Bay is trying to get any sizable, dense rock was the challenge, and the rock required for the exposed berth was quite significant, and obviously the criticality of that rock, because you can't actually come back in and replace it afterwards, as opposed to a normal breakwater armouring. So it led us to firstly into a high density large rock, and sourcing that from out of Hawke's Bay was obviously quite a expensive operation. So yeah, we leaned towards the concrete armouring options, but also the challenging nature of trying to design an armouring option that works around the pile positioning was the struggle. So once you start looking at any of the X block options or any of that, there's no evidence of it being used around piles. And obviously with X blocks and similar types of matting revetments, if you have gaps in the revetment, they can unstitch themselves quite easily. So that's where we moved to this block option, which we had previously found information used for breakwaters, which then allowed us to set the positioning to place them around the piles.
Well, Chip, the question was, what was the rock layer we drove the steel piles through?
The rock layer is in the limestone.
So that was the limestone, yeah.
Yeah, so the existing revetment was the limestone armoury.
Yeah.
We obviously couldn't use that material for those reasons I just mentioned. So that material was pulled out, although those limestone rocks were pulled out. But you're pulling rocks out from underwater, you're never going to get them all. So the challenges with the piling arose with some of the rocks still being in place.
Yeah, and that also was issues with our CSM cutter saw mixer finding those rocks. Yeah.
Thanks, mate. I appreciate it a lot. That's awesome.
I'm Andy Brown, part of the PIANC committee and engineer with Tonkin and Taylor. I've been asked to just jump up and tell you a little bit more about PIANC. So does anyone know what PIANC stands for?
No.
The chair doesn't, so that's a good start. No, so it's the Permanent International Association of Navigation Congresses, which is obviously a bit of a mouthful. So it's now referred to as the World Association of for Waterborne Transport Infrastructure. It's been around a little while, 140 years or so. Its primary function is basically to bring people together that are working in this industry so that knowledge can get shared. And as Matt was saying earlier, kind of one of the big key outputs of PIANC are these technical publications, which you're probably quite familiar with. Some of you might be as design engineers. And they're developed through a series of technical working groups through these 4 commissions. So you've got the Maritime Navigation, Inland Navigation, Environment and Recreational Navigation. So they bring together experts from around the world to create those working groups, go on to create the publications for use by us. Another key thing is PIANC aims to support your career by mentoring, providing a platform for networking and events like this. Yeah, I'll probably just leave it there for now, but I'll jump up later and tell you a bit more about the benefits that you get being a member. I'll hand over to the next presenter. I think it's Gabby, talking about the Seaview Wharf renewal.
Good evening, everyone. I'm Gabby, and I work for Brian Perry Civil. And I'm going to be presenting on review Seaview Wharf Resilience Project. I have been working there for the past 2.5 years, so I know a little bit about that project. But also, we have a lot of people here that work there. So if I say lies, you guys feel free to tell me off. I'm going to start with a picture of Seaview Wharf here. This is a picture from 2022 when we just started the project. The wharf is a critical asset in New Zealand. It's an unloading facility for fuel and chemical tankers in the lower of North Island. It's currently serves approximately 20% of New Zealand population. The wharf was constructed in the 70s and now requires some upgrading. And also after the Kaikoura earthquake in 2016, the structure got quite damaged. So that's one of the reasons we are also doing this project. This is a summary of how we are delivering this project, and feel free to compliment us how creative we are in naming the stages of the project. We have 3 stages, 1A, 1A plus, and 1B. And for 1A, we are building 3 new structures around the main wharf, pile cap at the back called PC1, and 2 new berthing dolphins on each side of the main wharf. The berthing dolphins are connected with post-tensioning tendons, and the PC1 is connected to the existing structure with post-tensioning stress bars. 1A plus relates to the works around the main wharf extension, and we are building 1 new structure at the back of the main wharf extension called PC3. And stage 1B, it's about the new 2 mooring dolphins that we're building on each side of the wharf, MDA and MDB. So that's the stage 1A. So we have a pile cap at the back and 2 berthing dolphins on each side of the main wharf extension. Like I said, they are connected to the existing structure. The berthing dolphins connected with post-tensioning tendons, and the pile cap at the back connected to the existing wharf with post-tensioning stress bars. We are also to make the structure a little bit more seismic resilient. We are also installing some gravity clamps under the wharf around the existing raker piles. And to make it more seismic resilient, we are also disconnecting the main wharf from the main wharf extension. So on the side of the picture here, you can see that this is going to be demolished after we put BDP in there. Here, just a picture of the gravity clamps that we're installing around the raker piles at the moment. So after we have all the new structures installed and post-stationed, we are going to install some jacks on each side of these gravity clamps. We are going to jack the wharf a little bit, cut the raker piles, so you separate the existing structure from these existing raker piles, and then remove the jacks, and then the structure is going to sit on some plates. Stage 1A plus, it's basically a new structure on the back, and it's connected to the existing structure the same way as the pile cap on the back of the main wharf extension, with post-tensioning stress bars. And stage 1B, 2 new mooring dolphins, A and B. And on MDA, we are, after we finish building the new mooring dolphin, we are also going to demolish the existing one after the new one is up and going. So during the presentation, I'm gonna focus more on the challenges with the construction. And because we're talking about Seaview, the first thing that we talk about is location. So the area is extremely exposed to high winds, especially the southerlies, which makes the job quite interesting. I have put a few pictures here from when we first built one of our jack barges. At the time, the barge was floating in the water, and then, yeah, after the storm, it wasn't kind of floating anymore. This is a picture from August 2022, I think, but since then we had several events like this. So every single thing that we do in Seaview, we need to think twice how to do it, how to be more efficient and how to be safe as well. This is one of the reasons why we need to do the project mostly from jack barges. So we have installed temporary staging structure close to our compound to assemble the barges and to load and unload the barges as needed. So the good thing about jack barges is you load the barge as soon as you are located where you need to be to complete the works. You jack it up. Usually we jack it up to a meter and a half above high tide to allow for waves or storms, so it doesn't affect the barge. And then you have a very stable platform to work from. So that was one of the reasons that we chose to do, the job was chosen to do from a jack barge. So this is the video of one of our jack barges with the 250-ton crane on the deck. So that helps to complete the works for piling works and to do all the heavy lifting on the wharf as well. Space as well is another thing. We don't have a lot of space on the wharf, so because of the situation with the structure, we don't have a lot of opportunities to put equipment or tools or material on the wharf. So we kind of found space to set up our compound, but who's been in Seaview before know that it's really tight anyway. So we have a bit of a lay down area, but not much. So we try to make things. We try to reduce the amount of work that we do in situ. So the more we can do off-site and just bring it to site when it's ready for installation, we try to go that way. Another challenge that we have is the environment. So Seaview Wharf is located within the Wellington Harbour, which is the habitat for several species, marine species. So we need to be careful when we are working around them. An example is before we even started the project, before we even start building our staging, we had to find a way to protect the penguins nesting around the riprap on our compound area. So we found a solution that installing a netting on top of those rocks would avoid the penguins from going back to their habitat, which is not very nice, but it worked. We put some boxes outside for them, so in case they wanted to go back and really nest in there, they had those boxes outside. The good thing is it worked because we keep finding penguins inside these boxes. So I think they like the boxes. We don't have the netting there anymore because now we are mainly working on the wharf. Down the end of the wharf, so it's not noisy anymore for them. So we decided to remove this netting. It wasn't a very good solution because it was really hard to maintain the netting. So basically on a daily basis, we had to have someone there fixing holes in the netting, and they're very tiny. So even like small holes, they would go through, and so it wasn't a very good solution, but it was what we found at the time. We had to put a lot of management plans in place to start the project as well and abide by the rules of our resource consents. Another challenge is, and this is a big one, throughout the project, the wharf remained operational. So we work with outages. So we have 2 weeks outages where no ships can berth on the wharf, and then 2 weeks we need to work while the ships are in there. So we came a long way since we started the project. At the beginning, it was really restricted. We were not even able to walk down the wharf. The fuel industry didn't want us around them. But then after a while, Centerport managed to get a matrix of permitted operations to have us working around those ships when they were there. So these days we are able to do a few things. It is still quite restricted, so but much better than it was before. Piling. So constructions aspects of piling. So here's a photo of the drill rig on the barge and some piles already installed, and the drill rig drilling one of the piles. The piles are 1.5 meter, have a 1.5 meter diameter. The casings are about 23 meter long, 25 meters long, very heavy. So we're glad that we have a big barge that has a big capacity to lift everything in place. One of the dolphins it had to be done from the wharf deck, so which is the picture on the left side. We had to place some beams in there to transfer the load through different bends on the wharf. The middle photo is piling for the mooring dolphins. The thing with the mooring dolphins is because they are so far away from Seaview Wharf, the ground conditions is a little bit different. It's a little bit softer, so the casings had to be a little bit longer, about 5 meters longer, which made things a little bit more complicated. So we are not able to lift everything in one piece anymore. So we need to splice it in place, which makes things takes a little bit longer to finish one pile. The photo on the right is one of the concrete pours that we're doing, a tremie pour for the pile. We need to overpour 500 mil to achieve good quality concrete from the bottom to the top. And the skip on the side is to catch all that slurry, and the overpour as well. So the team doesn't need to come back later and break concrete, because you can imagine how hard it is to break concrete in the middle of the ocean. The concrete cutoff level is really, really low as well. So it's really hard to work there when it's high tide. When we are doing a concrete pour during high tide or with a little bit of bad weather, we are not able to do this. And then we need to overpour, leave it there. And then the next day, the guys would go back and break the concrete. Another thing that we did in this project was to implement a different type of splicing on the cages. So in New Zealand, usually when you splice cages, you use U-bolts. So the guys need to put their hands through the cage and splice every single bar with U-bolts. Because the cages were very long and very heavy as well, we came up with this idea of installing a super latch. We call it super latch in one of the cage sections, and some plates on the top section. And then when you install the top section, the plates goes inside the super latch and it locks. So you save some time and you remove the risk of the guys having their hands through the cage as well. When we're doing piling, we also need to monitor the electrical conductivity of the water, because Seaview Wharf is located in the Waifeto aquifer area. We need to keep an eye on that. We also need to do underwater noise monitoring, because when you install the casings with a vibro hammer or a drop hammer, and when we are drilling as well, there's quite a lot of noise underwater. So we install a bubble curtain around the piles. It's basically some pipes connected to a compressor that release bubbles, and that curtain of bubbles mitigate the noise dissipation. One nice thing was the first bubble curtain that we bought before we started the project was from Canada. And it was just a massive pipe that we had to put around all the piles, and we had to use divers. We had to put weights on it to keep at the bottom of the seabed. And as we went from one pile to the second to the third, the site team came up with a very good solution, which was building a new bubble curtain that would go around one pile, because we only do one pile at each time anyway. And it works even better than the one that we bought. And I must say, the one that we bought was really expensive. Precast elements. So like I said, because the location of the works and the weather and the level of the wharf, it's really hard for us to do everything in situ. So we had several meetings with Centerport and the designer as well, to come up with a few ideas in how to build those pile caps. And the solution that we came up with was building a precast soffit. Usually is between 250 to 275 mil, and then place on top of the piles, and then we wouldn't have to do any false work. It worked, but there's also a few challenges there. Like first of all, was the lifting was quite complex because it's not very thick and it's really heavy. So this is the biggest biocap for this stage 1A, and it weighed about 72 ton. We are building this at our precast yard in Aotearoa, so it's about 45 kilometers away from site. And we have some challenges with lifting because we use our gantry cranes to lift and they don't have a lot of headroom. So here's a photo of the first soffit being lifted onto the transporter. Also, for different PIANCs, we did we tried to improve and do different things. So for PC1, because it was so massive, it was 15 by 8, so it was really heavy. You couldn't fix any steel before you transport it to site because it was already too heavy. But for BDA, and that's how we're going to do for BDB as well, and for the Marine Dolphins as well, we finish the soffit and we fix the steel all before bringing it to site. And then once you land on top of the piles, you just basically need to put the shutters, do a few bits and pieces, and it's done for. It's ready for the in-situ pour. Here's a photo of the guys doing the lift on top of the piles. For PC3, the structure on the back of the main wharf extension, we decided to do a shell, because we thought, oh, shutters are too difficult to do on site as well. Let's turn into a shell. It was hard. It's hard to lift, it's hard to transport, it's hard to fix the steel after it's on site because this is probably 40% of the steel that we had to fix. The rest had to be done on site. It was really hard. Lots of people complaining, so probably I would go back to those soffits. Here's a photo of the PIANC being brought to site. Once the transporter is on site, it unloads straight onto the barge. When we take the barge to its final position, we need to worry about the stability of the barge. It also needs to be, the movement needs to be done on a day like this, when it's really nice. It doesn't need to be sunny, but it needs to be, we can't have any wind. Because we have a 250-ton crane, the barge itself, it's really heavy, and the PIANC weighs about 72 ton. The freeboard is only like 500 mil, 400 mil on the barge. So we need to be really careful with every single thing that you put on the barge by the time you were doing the movement. Photo of the barge getting close to its final position. And here's a video when we land the PIANC. There is the crane needs to be in a very specific place on the barge to not overload the legs of the barge as well. You could use the buoyancy of the pontoons because the barge is made out of pontoons. So you just connect pontoons together, put 4 legs on each corner, and then you have a barge basically. So if the PIANC is too heavy and you need to get to the very edge of the barge with the crane, then you could use the buoyancy of the pontoons to help you keeping stable. In this case, the barge was a little bit above the water. In situ works. So I just put a few pictures here for you guys to see how hard it was to work around the wharf. The level of the wharf is really, really low. We need to have handrails everywhere. We need to have platforms everywhere. We need to have access to under the wharf everywhere. So most of the works on site are done by from the boat or from these platforms. Here more platforms. Here's a photo of the platforms that we had around BDA and PC1 after a bad weather day. So we came back to site and they were all gone. Like lucky enough, we had finished the works in there, so we were about to remove anyway. But I think that showed us that we made the right decision to go with precast soffit and avoid doing more in situ works. These are the platforms that we installed at the beginning of the job to start the works with the gravity clamps, because before you start the gravity clamps, you need to clean the piles, you need to do a bunch of things under the wharf anyway. This is probably one of the hardest jobs that we need to do on site, because here it was a high tide, almost high tide, and you can see what is the clearance that the guys have under the wharf. So it's you just have probably about 3-4 hours to work on a daily basis, and they still have like wetsuits and special PPE to work under there, but it's really hard. Here is a photo of the guys grouting one of the gravity clamps. So the platforms that they are standing on, it's a fixed platform that we put at the beginning of the job. Yeah, but there's not a lot of space for them in there. Photo of Olga, very proud of her gravity clamp. And here is just another photo of, because we have tried different types of platform under the wharf. So the first one, we're happy with the first one. The only thing is, like, you can tell how much seaweed you have around the platforms and stuff like that. So it's not ideal. Also, very frequently we go back to site on a Monday and the platforms are not there. They are in the bottom of the ocean. And then we need to send divers, then divers pick it up, bring it back, and we basically start from zero, inspections again, checking every single boat, blah, blah. So it's a big deal. So we tried to come back with different solutions. One of them was this scaffolding platform that you pull it up every time there's a bad weather coming, and then you put it down when it's all good. But sometimes the forecast is not good and you're not quick enough, and then it's all gone again. And yeah, so we're still trying to find the best way. So if you guys have any ideas, please let me know. But yeah, we are getting there. So far we have finished almost all the piles. We have 2 piles to go that we should be finishing next week if nothing goes wrong. And we have finished PC1 and BDA, and we have done the precast for BDB already, and we are starting the precast of the mooring dolphins. So yeah, it's going well, but lots and lots of challenges. Any questions?
Wouldn't do a shell beam again? You just do this software.
Yeah, probably not. I didn't really like the shell beam, unless they were smaller. If they were smaller and they were lighter, then we would be able to fix the steel before bringing it to site. But it was really hard to install the steel on site. It was extremely hard, and they are 18 meters long, I think. So they're very heavy. So we couldn't do much. And then you had steel coming out of the walls.
I was just going to say the issue in terms of getting inside and fixing the additional steel.
Yeah. And you also had some steel going through the piles. So, like the piles, we do our best, but some piles don't align. So then you need to install like a piece of steel, and then you need to go again and put another one. So it's not only about, running the steel on the sides. It was really hard.
Melvin might be able to answer.
Cool.
Why are the new structures post-tension to the existing structures?
The new structures provide the stability to the existing structure. So when the lateral resistance is removed, when you remove the regular piles, the stability comes from the dolphins either side that are clamped to the existing. and it provides a ductile connection because it is inherently ductile. The steel tube plus steel up into the pile cap will perform much better in an earthquake event than the regular piles would.
So is it almost a seismic retrofit to the existing structure in terms of utilizing the new structures?
Yes.
Okay.
We like to say that the new structure being built around the main wharf is kind of hugging the existing structure and taking it together.
See any more?
Cool.
Nice.
There is one more, sorry, from Thomas Anderson. If you look at the Q&A tab at the top.
Oh, thank you.
Natasha to review that.
In terms of environmental monitoring, are you completing real-time water monitoring? Same for noise and dust, or is it retrospective?
Real time. Yeah, it's real time. For the noise, underwater noise monitoring, we need to do every time we are installing the casings and every time we are drilling. For noise in the compound, it's real time as well. If we don't do it, we receive real time complaints. Yeah. So yeah, it's definitely real time.
I think that's it, unless there's any more from Auckland or. Cool. Thank you so much, Gabby.
Hello again. So we've got 2 more presentations to come, but I'm just going to quickly run through some of the benefits of being a PIANC member. So you obviously have access to the technical publications, which I was talking about earlier, but you've also got the opportunity to be on the working groups preparing those. So if that is of interest, you can jump on the website and check out which working groups are looking for new members. Of relevance to a few of you are the new Fender guidelines, which came out very recently this year. Other benefits are these events that we put on. So we're, as a committee, continually thinking of ideas of what might be interesting for the members. But if you have ideas or sites which you think would be suitable for a technical tour or a topic of interest, then yeah, reach out and let us know. Jono is going to give a bit of an overview a bit later about what we've got planned for the rest of the year. And then online, there's a bunch of previous event recordings and webinars, so you can take a look at those at your leisure. And then there's also this kind of mentoring program as well. So if you've got some wisdom to share or you need a bit of guidance in your career, then you can sign up to be a mentor or mentee. And then I guess the last thing is if you've done something cool or interesting you want to write up about, you present at a conference, and you get the possibility of winning an award through PIANC, and they get presented at the PIANC conferences. So that's all from me. Pass over to the next speaker. We've got Melvin and Chris talking on the Southport Town Wharf project. Thanks.
Great, okay. This presentation is going to cover the design and construction stages of the town wharf rebuild in Bluff, completed for and with Southport in 2021 to 22. Speakers are Chris Hewitt, formerly engineering manager for BPC, and now the manager of PIANC and geotechnical leader consultant for BPC. My name is Melvin Auld. I'm a technical principal in ports and marine structures at WSP. So we want to cover what did we design and build, why and how. So Town Wharf is a new pipeline corridor, access structure and discharge structure for petroleum import activity. Berthed alongside the almost finished berth in this photograph is the 183 metre long Nord Minute. It was a Hyundai Mipo built from 2009. Tragically, for anyone here interested, in MIPO have some fabrication windows open for large vessels. We're going to get into some of the detail of what was built, why it was built, how, and lessons learned. The Sydney vessel Perseverance, it sailed into the harbour in Bluff in 1813, found a Ngāi Tahu settlement on the seaward side of Motupuhui, which is Bluff Hill. Bluff boasts being one of the earliest and continuously European inhabited settlements in New Zealand, although it was known as Campbelltown until 1917. It's only worth mentioning because where I'm from is close to Campbelltown, and Campbelltown is the home of Springbank whisky. The tenuous link here is that the head of Ports, Marine and Aviation after this presentation is buying whisky. So Bluff, well, the marine activity in Bluff started as a vessel supply post and then a shore whaling station established in the 1820s and 30s. Town Wharf itself was, construction commenced in 1863. Then the Island Harbour Reclamation was constructed in the late 50s over the shallow sandbanks west of Town Wharf, and the main activities of Southport business are centred there on the reclamation. Port throughput is about 1.7 million tonnes. So you can see Town Wharf close to the harbour entrance, the Island Harbour Reclamation, the township and Bluff Hill in the pictures that are borrowed from Southport's website. The Town Wharf structure has been modified through the years. Berthing and mooring of demands from large tanker vessels, obviously exceeding the capacity of the original wharf, even if it boasted an undeteriorated state. The Berth 11 arrival passage plan gives a good feel for the geography of the site. As I said, structure was inspected periodically. A reduced level of service, localized cordons included in a condition report in 2006. Wharf was reported as beyond routine maintenance, with physical remaining life exhausted by 2016. Conclusion that reactive and continued maintenance were required to preserve its useful life. But we're seeing this sweat the assets, extend the service life, deferment of maintenance across multiple infrastructure clients, across lots of industries and across ports. But ports are doing a great job on limited budgets to manage asset condition, to manage level of service requirements, to assign priority to competing cost centres, a real unenviable task. I'm reminded of a mid-lockdown webinar by the then head of structures at KiwiRail, who described rail engineering as aged care. So, SPNZ, they commissioned the design of a new access structure and discharge platform late in 2018. So replacement design was developed using a fairly typical form, the shortest route from A to B, which is shown in the blue hatch on the screen. You can compare that to the as constructed red. Tender return for the blue scheme was more than the budget. There is a massive lesson to be learned here, and it would take someone a lot braver than I am to expound on it, but budget setting with known unknowns, with unknown unknowns is fraught for designers, contractors, clients and boards. Contingencies, escalations, risks, price realism before the outset is a real minefield. The New Zealand Inc. recent project experience proves that no matter how on the hook a client might appear to be for ferries or schools or cycleways or public transport or waters 1, 2, 3, 5 or 7, resilience projects, shovel-ready projects, RMA fast-track projects, cost increases from old and optimistic budgets, they carry risk. And as a wee bit of a side pitch, the array of inspection, repair, replacement, strengthening and new build projects that we have means we have a bank of info to help with a large number of insurance valuations across ports in New Zealand and Australia. Cool. So yeah, look, as Melvin said, I'm Chris, and at the time of this, I was the engineering manager for Brian Perry's.
And so I got pretty heavily involved in the ECI process that we ended up in. And that's how I got roped into this. So as Melvin said, the design that was the original design there that we got to tender. It was pretty robust and it needed some pretty significant temporary works. So we were looking to actually build basically a staging that was going to run right next to that structure so that we could get craneage and stuff out to the wharf to load the big heavy precast elements in. We actually came up in our original offer, we came up with that little very technical looking sketch there, which we actually included in our tender, which is basically some pink pen and some pink highlighter to show where we would put the crossheads, we would put the piles. And that was done so that we could use our temporary staging beams, which are about 9 meters long, and drop them in on the permanent pile, similar to the way you guys did out at Napier, just to try and avoid putting in a whole lot of temporary piles. So based on that, we were the cheapest price, but we were still significantly more than Southport's budget. Didn't want to go. There we go. So we got the news that we weren't going to be building it because we were too expensive, and so we started to have a look at actually what this thing needed to do. So for a kickoff, it needed to support the discharge pipeline. Pretty standard. Needed to withstand highway vehicle loading, but it didn't need to take a B train. Like, just needed to be able to get a ute or a light truck out there. Needed a 50-year design life. Some things that were a bit nicer to have. Be nice if it was durable and maintainable. No massive value on functionality. This was definitely a function over form structure. And constructible in an operating port environment. So as Gabby alluded to earlier on, you've got to be able to stop and start like that. And just as I said, there, lower value on amenity. They weren't really that fussed what it looked like. So a few of our boys were on a BD trip down in Queenstown. How much BD actually got done, I don't really know. And they're sitting down having a cheeky glass of red wine by a fire in a pub that they still talk about. And they started to have a wee bit of a think about it and realised that our temporary staging actually ticked a lot of those boxes. And as Gabby showed earlier, when that barge was getting the shit beat out of it, it was up against our staging. And so we know that it's resilient. But there's a lot of things that it doesn't do, right? So it's only designed for a 6-month design life. It's only designed for a 1 in 100 year return period event. We don't really worry about corrosion protection because never around long enough to rust. So we sort of ummed and ahed and went, well, why can't we just build a galvanized staging? So brought up a few questions and things like, you know, we're obviously contractors with really big picture ideas, but not really many ideas about how to actually do anything. So to kick it off, we basically just priced up galvanizing some staging and, you know, allowed for a few more bolts and a bit more welding and presented that to Southport as a concept. And to their credit, they liked that concept and they took a bit of a calculated risk and entered into an ECI with us and WSP. And what was really cool about this, I got to play a pretty big part in it. Go and sit in WSP's office and draw sketches like that and think that they were just going to get thrown in the bin, and they end up in some of the design documentation, which is a little bit disappointing. So essentially the way it sort of worked is that we came up with what we could build and we just threw that at Melvin and his team and went, you make that work. And they did very, very well and made it work. So we did things like, you know, we knew that we were going to be using a 100-ton crane. We put the main beams at 4 meter centers because that's the track width of the crane. And then we looked at things like, well, how far can we actually lift to do the next bent section? So what turned out to be the critical thing was driving the piles, so having to lift a big dirty great 9-ton drop hammer. The maximum we could lift that was about 15 meters with the 100-ton crane. So that determined where the piles were going to go for the next bent. And that meant we could build the first bent, sit on that, build the next bent, walk out onto it, build the next one, and just carry on as we were, like we would install our normal staging. I guess there's a little bit of a comment there about we all love to talk about contractor-led design and how wonderful it is at ECI. There is a little bit of a risk there that you have to pick your contractor before they've had to go in through any price tension. So I guess the difference here was that we proved that we were going to be cost effective by winning the original tender. WSP had done the same by winning the original design contract. So yeah. We also, something that we did here was we brought in our supply chain really early as well. So we bought an East Bridge, so they were going to be they were taken right through the design process with us. So back to the smart man, it tells you how he actually designed it.
Well, as Chris said, we started with confidence that the temporary staging could support a crane. Started with a contractor who had proven the system in previous projects. We started with an optimized pile spacing in 2 directions to suit the crane track width and its reach and lifting capacity. All we had to collectively do was take a cantilever pile concept as used with plenty of embedment in decent ground and make it work for shallow embedment in poor ground. Take pinned top connections, make them fixed. Take a temporary staging, make it durable and stable for a 50-year design life. Take temporary construction loads, construction stage tolerances, relatively low important structure, and make it suitable for the support of an oil pipeline in an active seismic zone. Added to that, it needed to be transportable, suitable for handling, suitable for assembly from and over a deteriorated existing timber wharf. So of the challenges and opportunities, we'll get into some of those connection details shortly. But I guess the process was that we had a design workshop every couple of weeks as the design was being worked through. In those, the challenges were brought and solved collaboratively, and the client was involved in those workshops, leading to fewer assumptions being made by everyone involved and just a better risk awareness. One such risk that every geotech will claim is the need for more borehole data. When the client's in the room and the borehole data issue develops, they can see how it might be holding up a process or influencing the cost and contingency pot. You know, if a geotech engineer comes to me asking for more borehole data, or if I go to a client to ask for the same, I might not be able to demonstrate the benefits effectively. Well, the contractors seem to have that knack. Brian Perry's were continually updating their construction cost estimate at each design stage. And so together we were understanding the concerns, the risks, opportunities and potential solutions. All right, so this cross-section shows some of the component parts. If we start off at the bottom, if the piles had sufficient embedment into non-liquefiable weathered rock overburden, then the lateral resistance that we needed was inherent and everyone was happy. The peak pile axial demands happened during construction with the cranes on top, and that capacity was readily attainable. Where we had insufficient embedment, then we needed some other method of toe fixity or achieving lateral restraint. This was potentially costly, but was considered early in the design in order to take that issue off the critical path. The first stage of the installation process was going to be to clean out the pile. After that, the main construction work phase could move on, which was thanks to access through the main girder and top planks, where anchors could be drilled and grouted in by a following trade. The project spec required proof of concept in an early pile, also allowed calibration of the borehole data with the pile cleanout and the driving resistance, which Chris will cover shortly. Main girders, as we said, are in a 4-meter spacing. They also run 9 meters, I was going to say into the page, but into the screen. They're fabricated of 500 WC members. Those were strong enough to carry the crane, but shallow enough to shoot over the existing wharf. The girders and the headstocks are fully welded to what we call the pan. You might think of it as a spigot, which is inserted into the pile. Girders bear on the top of the pile, and then the moment transfer and shear transfer is through the keyed grout annulus. Top of the grout was hand-applied UA to reduce the risk of overspill, although during filling there was a catch cone, and then to prevent ponding and improve durability. The proof of can install and the grouting methodology was done in Brian Perry's yard in Christchurch in the months before site mobilisation. This involved proving an effective method for sealing the annulus. Okay, into some of the details themselves. You see a can to girder connection with the internal access sleeve. The biscuit, which was used to seal the underside of the can annulus, was attached to lines that were fed up through the sleeve to sort of get a picture of how it might come together. The bolted girder beam splices located away from the pile location, and then the stub crosshead and that girder both fully welded to the can, and a gusseted moment end plate bolted onto the transom. Piles were driven to close positional tolerance. Heads were cut off to the final level to receive the girders. And then the girders and cans and crossheads were all dropped as an assembled unit into the piles and bolted up. So you can see the sort of schematic sequencing for the access structure on the top, and then some of the sub-assemblies in the discharge platform on the bottom. Okay. So as Chris said, the contractor wants to drive piles, drop in the superstructure, drive piles, drop in the superstructure, drive piles. So, and so, you get the idea. But we had reasonable info on soil springs, on lateral capacity of the cantilever piles, in soils that were weak, but then liquefaction wasn't a concern during that temporary stage. We knew about the gap between the can and the pile. Knew about the frame capacity in the transverse direction, and so although the temporary works normally sits in the contractor's wheelhouse, there was strong encouragement for us to provide some analysis outputs and confirm just how far ahead of grouting up the cans the crane could sit. So a wee bit of analysis followed. You can see plan view, the in-progress wharf structure is going to behave a bit like a Virendale portal frame. So we modelled it with some springs representing the force displacement property of the piles, both cantilever piles and of fully grouted up bents, and arrived at the recommendation not to leave more than 2 bents of piles ungrouted behind the crane. So grouting was often done on a Friday afternoon or Friday lunchtime, and that left 3 days of no vibration curing so that concrete could come up to PASC. A wee bit just on importance level on NZS 1170 versus some of the international design standards. So Oil Companies International Marine Forum, silent on seismic design, but the International Guide for Oil Tankers and Terminals, it refers us to the Marine Oil Terminal Engineering and Maintenance Standards, which is a chapter in the Californian Building Code. So written specifically for marine oil terminals and in an active seismic area. The MOTAMS has oil spill exposure classifications and performance levels to describe the seismic performance criteria. We considered these aspects alongside 1170 for Town Wharf performance objectives. Coastal Oil Logistics had advised that pump shutoff would occur within 1 minute of a leak during fuel transfer. So we looked at the fastest discharge rate, allowed a wee bit of contingency on the time to shut down the pumps, and estimated that the maximum leak from Town Wharf berth would be about 10% of what's described as major leak in MOTAMS. We then knew that there would be bunding sufficient to contain that maximum possible spill at the discharge platform and at the interfaces of other, at interface locations where the wharf rounded the corner, where significant differential movements could take place. Then the pipeline itself was designed to accommodate those potential movements, and there was also appropriately sized and designed containment. So the agreed approach was to target in performance terms, the MOTAMS returns periods for performance, I guess, similar to NZS SLS1 and SLS2, and then to use NZS 1170 directly for ULS return periods. We provided estimated structural displacements for each of the relevant return periods to Mobile, and then they designed the pipeline and its details. And final slide from me, the coating spec was thermal spray zinc with a top seal coat with denso pastes and wraps protection to the bolts, denso jackets to the piles, And then on the upper cut surface of the pile and the inner 150 mil or so of the pile casing, there was brush applied epoxy paint coating.
So yeah, a corrosion protection system that was a little bit more technical than the candid cold galv that we put in the original price. I think when Melvin mentioned that I was a geotechnical person, it was purely so that I would do this slide. So the ground profile throughout across down the alignment was basically very soft over very hard. If you want to put a more geotechnical bent on it, it's marine sediments that were sort of between, well, they either weren't there or they were about 5.5 meters thick over a weathered rock layer that was a silty clay that was sometimes not there or up to about 3 meters thick. That was that layer that we were relying on being able to drive through to get our toe embedment, to get that toe fixity. And then this norite bedrock, which all throughout the ECI process, we were warned that a previous contractor had come a wee bit unstuck and had started referring to it as the hardest rock in New Zealand. I don't know how true it is that it's the hardest rock in New Zealand, but yeah, we weren't really that keen to play with it. So, few geotechnical challenges. Liquefaction triggering was expected in those marine sediments. This was only an issue for the permanent works design, so it did give us a bit of a win with the temporary works design because it meant we could rely on those marine sediments for a bit of lateral load on the piles. We did, however, have a bit of a crust that didn't liquefy on the top, and so when you did get that liquefaction event, you had this nice slippery liquefaction layer with this crust moving along the top of it that provided a heck of a lot of load onto the piles, and that was particularly niggly at the interface between the wharf and the reclamation. And then the other challenge, as Melvin alluded to earlier, is that normally when you're driving a pile, you're just driving it to an axial set. So we just want an axial load, we just drive it until it stops going. Thanks for coming. Here we needed to prove somehow that we got this toe fixity. Obviously the obvious one was to drill a rock socket. Normally if you're going to drill a rock socket, it's going to be, you know, if you've got a 600 diameter pile, you're going to drill a 600 diameter rock socket. Drilling 600 diameter rock sockets and what was being touted as the hardest rock in New Zealand didn't really fill us with joy. So we started to actually look at what load you needed for that toe fixity and realized that you could probably get away with something that was more like 150 mil. So came up with this concept of a shear anchor. Yeah, however, we still needed to work out. So the idea behind that shear anchor is if you don't get the embedment, then you have to put a shear anchor in. We still needed a reliable way of working out how we were going to determine whether or not we needed that shear anchor. So this was something we came up with during the ECI. We proposed that we would bolt PDA gear, pile driving analysis gear, onto the tubes as we were driving them. So, and then we would assess how far into the weathered rock we'd got using that. So I'll sort of talk about that a little bit later. But once we'd achieved that embedment into rock, we didn't actually need to anchor the pile. So we agreed the process that we were going to go through. You know, this is what we're going to do. We're going to bolt the PDA gauges on. We're going to work out whether or not we need to anchor the pile. If we need to anchor the pile, it's going to cost you this much. And it was a provisional item, so it was pretty much locked in. Clients able to go, well, okay, so if I need to anchor all my piles, it's going to cost me this much. If I have to anchor half of them, it's going to cost me this much. So they were able to do really good sensitivity analysis. So those driving correlations, as Melvin said, we drilled a couple of boreholes at a couple of the early pile locations and we logged them and we worked out where we thought the weathered rock kicked off, where we thought the borehole showed sufficient strength that it would provide that toe fixity. And then we drove a pile with some PDA gauges on it and we worked out what the driving resistance was at that point. And then when we were driving a production pile, once we'd achieved that driving resistance, we just kept going either until we got the set or potentially sometimes we got the set and we had 800 mil embedment and oh geez, it looks like something went wrong and we're trying to get you back on the call. Now we're back on the call. Yep, sweet. Right, so on the odd occasion we would get to 800 mil embedment and it was sort of like the question, well, do you want us to stop and we'll go and install an anchor, or do you just want us to sit on this for an hour and we'll just keep tapping this pile and see if we can get it to that 1.1 meters? Obviously, I'll go through a little bit of the process of cleaning out a pile in the next slide, but the client was much keener for us to just sit there and tap away for another hour. It's much, much cheaper than us then going and installing the shear anchor. So this is a little bit of an example that wouldn't believe it, but 2,000 kilonewtons was the number that we came up with for that driving resistance. It was a nice round number. No matter how many times I did it, it came up at 2,000 kilonewtons. And so what you can see there is that green line and the blue line are the penetration resistance per blow for pile A5 and B5. And once you get over that driving resistance at about 6.2 meters, we just carried on driving, and where we got the where we were able to drive it further, so you can see those ones there held up at about 8.3. 2 meters embedment. Thanks for coming. We've got our tow fixed today. We don't need to put a shear anchor in. If we did need to put a shear anchor in, this is what that started to look like. So even just dropping the piling hammer off and putting a Bonotto bucket on. Bonotto bucket's a cool little bit of kit, but they're certainly not the most technologically advanced bit of kit. And they are slow, and so we would have to just to drop the hammer off, pick that thing up, and start excavating out a pile. All that work, all that Bonotto bucket work, was on critical path. So we couldn't put the structure on. We could Bonotto out, and we didn't have to put the anchor in. But we had to do the Bonotto work before we could put the next bit of structure on. So it's a pretty sloppy, slow operation, and when it's on critical path, obviously it's much better just to do that extra hours driving. Cool. A little bit of chat about temporary works. Obviously, the first iteration of the design had quite a bit of temporary works. For the second iteration, for this one, pretty much about 4 items. So we had pile gates. Essentially, we had a big old timber wharf that was reasonably sturdy. We just cut holes in the wharf and dropped the piles through those. We did have to brace some of the deeper water sections because we had big free length on the piles, and so things start to move around. 100-ton cranes work better when they're more or less still rather than waving around. We had a bit of formwork for the discharge platform. That was just a pretty basic Doka system. And then this thing in the bottom right corner here is just a little access structure made out of slim soldiers that we lifted with the crane, dropped into place, and that gave the guys access to bolt up the next vent as it went on. That was pretty much it. So, I mean, in the entire project, about 4 items of temporary works. It really does ring true. The very smart man who used to be my boss a wee while ago, and he always said that the cheapest way to do something was to not do it at all. And so in this case, the cheapest way to do the temporary works was just to not do them at all. So yeah, that's pretty much it. Just some acknowledgements. Southport, really awesome to work with. Eastbridge, and Helidrill were our contractors who did the anchors for us, so it helped us come up with a way to put an anchor in 15 meters below the deck of a wharf. The pipeline stakeholders, berth users, Octa with a PM, obviously WSP, and yeah, so yeah, that's it. Thanks. Yeah. Oh, there's another photo about we won an award too.
What was the design construction program for that?
So we got each bent down to 3 days.
Shit.
So we drive piles on the first day, drop the each bent, like each little H section, we actually fabbed off site and just lifted it in one piece. So by the time we drove piles, dropped the bent in, put the precast panels on, and the next day, and then we were usually potentially some days driving piles 2.2 days later. Yeah.
And you'd always go out over the weekends, or were you? Yeah, okay.
Yeah. The whole team was working away from home, so not a lot of weekend work. So.
A number of anchors, Chris. So out of 56-ish piles, we ended up doing 3, 4.
3, yeah, 4, I think. 4. I think one of those was a test anchor too. Like, put it in.
Thank you.
What was the design like for it in the end?
The design life is 50 years.
50. Okay. And anodes on the piles?
Provision for future protection if required. Plenty of sweating.
Well, they made that last one last 120 years, right? So
animal.
Yeah.
Oh, hold on, there was a question there. Sorry, I'll read it out. Original design was pretty robust. However, when tendered, it was too expensive for the client. Why was there such a significant cost difference to the final BPC solution? Probably because the program was so much faster. So anyone who's worked in contracting knows that our costs are time related. Like it costs us a lot of money to be on site every day. And a massive saving on temporary works. Like we would have had to basically bring a whole lot of staging down from the North Island to do it. Whereas we just brought the permanent works down from the North Island and threw them in. So, yeah, quite a bit of material cost, but also time.
Was there a difference in design life though between the original design and this one? 100 to start with, and went to 50, or yeah.
Yeah, and some differences in performance.
Yeah.
I guess the other thing worth noting is that there was quite a bit of difference. So that form over function thing, like we wouldn't have put a 100-ton crane on the original structure, but you can actually, as long as you're willing to consider that you're not going to have a 50-year design life while the crane's on there, it's not going to handle a 1 in 500 year event while the crane's on there. You can actually throw a crane onto that and go and do some maintenance on the surrounding structures if you need to. So that was something that was that sort of functionality stuff that we got from, but it doesn't look anywhere near as pretty. It's a steel thing with some precast planks on it. Yeah. Sweet.
Kia ora everyone, Jono Stewart. I'm on the committee here for PIANC New Zealand. Good to be here. And great turnout. I've just been talking to the guys in Auckland. I think there's 10 people at our location up there, a couple in Christchurch. We've got 30 in the room here and about 40 online. So that's an awesome turnout, and hopefully we can continue this for the next event. We've already gone through the shout outs for the sponsors, but I just want to do it again. Thanks to WSP for tonight, for this location, for drinks, the venue and food, and same for Becca up in Auckland. Without the sponsorship, these events won't be at the same level, delivered at the same level. So definitely looking for sponsorship for the next event. So looking at contractors here and other consultants, that'd be great. Come and see me or Matt or anyone else on the committee. We'd love to talk to you, and we do have some exciting things coming up this year. Yeah, so back into it. Hey, look, what have we got coming up this year? I should probably click the next slide. This one here. Cool. So World Congress is coming up pretty quickly here. If you haven't booked your tickets, it might be a bit late. But yeah, 29th of April, 3rd of May. We've yeah, obviously Cape Town, South Africa, going to be a pretty amazing event. Tom, are you going to that? No. Okay, cool. Yeah, Andrew is. Yeah, Andy's going and speaking, which is fantastic. So is anyone else going from here? Oh, you are? Oh, nice. Awesome.
That's an excuse to go to Cape Town.
Exactly. Yeah. Nice shout. Yeah, cool. Excellent. And what else have we got coming up? 19th of June. We've got the annual general meeting in Australia. We've got another event coming up in July, which we haven't kind of set the date for yet, which is kind of a bit of a work in progress. Keen to hear what you guys are interested in us talking about next time, or what the theme of the event should be. So definitely keen to chat to you after the session today about that. We've got a few ideas, but definitely keen to chat to you about that. Similar forum to this, we'll probably have 2 or 3 live locations and then just do it online, or it may just be all online. We'll decide in the next few weeks here. 29th of August to 30th of August, we've got the big one for this year, which is in Australia, which is the Asia Pacific Conference for PIANC. Went last year, it was awesome. Going again this year. Tom's going. I don't know if anyone else in the room's going here, but this is definitely one it's worth going to. A really good networking opportunity. Yeah, lots of stalls set up, learning about different products, but also having some really good technical talks as well. So highly recommend it. Also good if you like a few drinks. 2 days left for abstract. Is that? Yeah, cool, sweet. Yeah, they've extended it by another week, right? Yeah, great. So yeah, definitely get your abstracts in if you're interested. Yeah, exactly. You could just submit what you've just done on a little bit of a thing. You'd be good to go, I reckon. Cool. And then look, we are currently planning for a larger event in October, probably a 1.5 to 2 day event on the back of the Ports Engineers Forum, which is normally hosted in around October, date to be confirmed. It is in New Plymouth this year. So yeah, we're planning a 1.5 day conference on the back of that. So everyone that's going to be going to that conference, they can just stay on 1 or 2 extra nights, and then hopefully everyone else from around New Zealand can fly in, and we can do a couple of site visits and some technical talks, and obviously a nice dinner out or something fancy, which will be good. So more information to come on that one. Does that move over?
Camera's right there.
Oh, that's right. They don't need to see me. It's all good. Yeah, more information to come. on New Zealand events, and obviously 2025 Coast and Ports Conference as well. More information to be shared around. Hopefully everyone here is like a registered member of PIANC, and if you're not, come see us after the session and we'll get you on the list. And if your company is obviously interested in becoming a corporate member, we can sort that out as well. So cool. And thanks again for everyone coming. And the next speaker we've got, who is the next one? Oh, this is the last slide here. Oh, cool, mate.
Hey, I'm Kyle Marshall. I'm a project engineer. I've been working for the past year and a bit on Seaview Wharf with Gabby and the team, doing a bit of piling work there and been heavily involved with that project. But I've recently just moved on to Matrix Islands, where we're going to be renewing a wharf on the island there in the middle of Wellington Harbour. I've only been on the project for 1 month now, so unlike the other presentations, I'm going to be talking about what we're going to be doing very shortly. So I don't have a lot of interesting photos and images and stories about what we've done, but I do have the scope of work, the design, and what we plan to do in the next 6 months. The good thing is I've got the two designers in the room, Tori and Ollie, so if you've got any questions about the detailed design, you can ask them the questions at the end. Okay, so just a bit about who's who on the project. So Brian Perry Civil are delivering it as the contractor. The client's Department of Conservation, and it's Homes that have designed it. And yeah, as I said, we're on Som's Island, which is situated right in the middle of Wellington Harbour. The existing wharf is just sitting in the top corner here. The existing wharf was built in 1908, and it's been servicing the island for a long time. The structure is in a very bad state, so we're going to be demolishing the existing wharf and rebuilding a new one. Some other bits of the scope of the project. So we've just finished site establishment and we've arrived on the island with all of our equipment and offices. We've got a boat ramp to construct. We've got the old wharf to demolish. We need to construct a new seawall, construct a new abutment wall, and then finally construct a new wharf. So just a little bit about the layout of where the works are. So we've got a very tight site compound. As you can see, the new wharf is directly over where the old wharf has been. So we need to demolish the old wharf first, and then we can get our barge in and start the piling works for the new wharf. We have an sea wall that is just to the south of the new wharf, and we've got a boat ramp to service the vessels coming on off the island. So I'll go through each of the aspects of the project and the methodology just from a high level, and then maybe into some of the challenges we're looking just in the planning stage before we go on to some of the other project challenges. So we need to build a new boat ramp. One of the challenges here is we need to create dry working conditions because the boat ramp goes down into the water. We've been looking at how we do this because we've got a very tight budget. So obviously you could build a cofferdam, but we don't want to go down this route. We're looking to use some of the existing site backfill and some of the engineered backfill that we bring in onto site to create a dry working area as a bund. Then we need to excavate down to formation level, install the formwork, backfill a sub base of AP40, lay mesh and pour the slab. Some of the challenges that we're facing so far with this planning this works is getting concrete to the island. So because we're building a boat ramp on a grade, we need a fairly stiff slump to pour that boat ramp. This is becoming very challenging because the concrete needs to stay workable for over 2 hours from batching over onto the island. We've got around 28 meters cube of concrete to pour, so we also need to get that onto a barge, float it over and pour it in the boat ramp. This is becoming very challenging as we've done 2 trial mixes to date and they both haven't been very successful. I'm working with mix designers at Wharf, who's our supplier, and we're trying to work a third trial to try and make this work. So then we go on to demolishing the existing wharf. So we've got a couple of things here. We're going to remove the existing wharf crane, remove the wharf furniture, saw cut the concrete deck, remove the deck using an excavator on a floating barge, remove the joists and remove the timber piles. So we're going to use a 30-ton excavator on a floating barge. We're going to sail it round. We saw this as a cost-effective way to reduce time in the programme, because initially we were going to use a little 8-ton barge and a smaller excavator. So we can lift larger panels. We need to do less trips back to Seaview, where we're going to be servicing the project, and we can take most of the wharf on that barge in one go. So a couple of challenges here. The wharf's in quite bad structural condition, so we've submitted our methodology over to Homes just to get a prior check to make sure the stability of the wharf as we deconstruct it isn't going to fall over. And then environmental control. So we'll be looking to place a silt curtain around the wharf during this demolition to stop any sediment or any debris falling into the sea. Next is seawall construction. So we need to demolish the existing seawall. This involves excavating the existing ground back and breaking out the bedrock. The bedrock sits underneath the water in the tidal zone here, so we need to actually excavate underneath there. Then we'll be placing magnum stones in the tidal zone, backfilling behind the magnum stones, placing Duramesh baskets and backfilling behind, and then we pour a new concrete slab on top. Some of the challenges I've been facing in the sort of methodology stage is how when we break out that bedrock, how we get that nice and level for the precast magnum stones to go in. And then the other thing is how we actually place the magnum stones so they're in a nice line. If we had more room in our budget, we'd maybe use a system like Luke used. But as we're only maybe in knee-level water, we're probably going to go with the old-fashioned method of having a guy in waders and probably a surveyor trying to line those in. So just a couple of things in the methodology there that's going to be quite challenging. So now we get into a bit more of the meat of the project, which is the abutment wall and the wharf itself. So we are going to demolish the existing abutment and we're going to put a new abutment in, which is made of precast concrete slabs. To do this, first of all, we need to install 5 number piles around the existing abutment, and then we'll place our slabs against that. After we've placed the slabs, then we can go ahead and concrete those slabs into place, continue our backfill, and land the capping beam on top. Couple of issues we're having with the methodology as well, similar to the magnum stones, is working in that tidal zone. So we are going to be breaking out the bedrock to land the precast in. We need a nice level surface. And then also we're going to be pouring concrete in that tidal zone as well. So we need to be working at low tide, and we need to have anti-washout admixture into our concrete design. So we're working with Wharf to get that mixed design developed, and doing a few trials with that as well. This is the 3D image of the new wharf. So the wharf's roughly 37 metres long, and we'll be installing 17 number reinforced concrete piles at 600 diameter. We'll be using the exact same methodology as Gabby showed at Seaview with a jack-up barge, 150-ton capacity, and working our way out from the abutment back as we install the piles. So as I just said about the piling methodology, we'll be using the jack-up barge. Something to know about the piles is we have got very tight tolerances, around 40 mil, to get that pile in the right position. This is due to the design. We've tried to make the piles smaller and make sure they're working efficiently. And because we're doing all our precast panels, it becomes a very tight tolerance. So to manage this tight tolerance, we've been working with our precast yard in Aotearoa, and they've come up with a system where we will precast all the bent beams first of all, and then we'll actually precast the slabs as they will be built in situ. So a build it before you build it approach. So essentially we will be building the wharf deck up in a precast yard before we transport it to site. That leaves us on site to manage the tolerance for the piles, and the precast tolerance has already been dealt with up at the precast yard. Something that I've been working on in the last couple of days is we originally went to tender and we said we would clamp underneath, clamp the pile with a friction clamp before we landed the beams onto it. We've kind of just figured out recently that this is going to be very difficult to do for two reasons. Installing the clamp as we're piling, the crane's going to be busy, so we don't want to be trying to install a clamp with men in the water, men in a floating pontoon. And also when we go to de-stress the friction clamp afterwards, we would need to make sure that there was no corrosion on the stress bars, and this would be difficult to do as there would be in the tidal zone. We're looking at doing a different system which would involve something similar to Luke's project where we weld brackets onto the pile. They're not going to be taking a lot of load, so we hope that we can do this from a boat/pontoon, and I'm working on it with the Temporary Works Department at the moment to try and develop that design. Finally, something to mention that's very important to our client, Department of Conservation, is biosecurity. So this is a challenge overall to the project. We need to make sure everything, including people, are all biosecure before we get there. So that includes our vessels, jack-up barges, materials, and literally everything we take to the island. We do checks every single morning. We do checks every time the materials get transported. And we work full-time with a biosecurity officer from Department of Conservation. So they keep us right, they're the experts, but we try our best to do all our checks before they come and do the final. I know that was quite a quick presentation. I don't have a lot of interesting pictures, but if you've got any questions, please let me know.
You got any more consent conditions at that location compared to the Seaview?
So we've got similar consent conditions in terms of the aquifer. We are a bit more free with noise as we are out on the island, but we have conditions around light. So because there's a lot of habitat on the island, penguins, tuatara, such, we can't work in darkness. So we can't illuminate the island. It needs to stay dark. So that's quite a constraint for the contractor, because obviously if you start falling behind program, what do? You put on a night shift, you work later hours, whereas we don't have that option here. So yeah, that's a constraint as well.
How far away is the island from mainland?
So we leave Seaview Marina. That's where we leave every morning, and depending on the sea state, 5 to 10 minutes on a vessel. So we currently have a small vessel which we take over. We can take 6 people on the vessel, and we do 2 trips each morning. As we get more into the project, we might need to up those trips as our crew gets larger, or get a bigger vessel.
Yeah. Okay. Run out of supplies. It's a pretty quick trip to.
Yeah. Yeah. Which we've already found. Questions?
That one just come off there online.
Oh. So did you consider precasting boat ramp panels and floating/dragging them into place rather than casting concrete? So this is something we've actually been discussing with our team over the last couple of days, and it's not something we've considered so far, but it might be something we consider in the next couple of weeks. Because we thought the concrete trials would go better than they did. We are looking at alternative options at the moment. So the issues with the boat ramp precasting is there's a shear key around the full perimeter, and it would be quite difficult to install that with the precast. But that's Tori and all they're probably listening going, are you? But yeah, we've been having a few discussions over the last couple of days on how we can get the concrete over there for this boat ramp.
Is the designer, sorry?
Homes.
Okay.
Yeah.
You got question. You've got pretty hard timeline, like delivery timeline.
Yes, so we program project completion is due in November. Obviously, that's not a long time from where we are now, and we've only just started the project. So yes, you're right, very tight timeline. Due to that, we need to do the planning very quickly, and I've been flat out over the last month trying to get all these plans together. And as you see, there's still a lot to figure out. So maybe in the next 6 months, if there's another one of these presentations, I'll have lots of lovely photos, and I can tell you how all the challenges that we've done, like the other projects. But at this stage, yeah, I'm flat out writing methodologies and try to figure out what the challenges are.
Happens in November, is there?
So DOC have already put on their website to the public that
CTG site.
the Wharf's going to reopen in November. Rightly or wrongly, they've put that out to the public. So we've got quite a hard fixed deadline in terms of reputation. Obviously, there's LDs and all that stuff. There's stuff in the concrete.
There's a ferry coming, right?
Sorry?
Ferry starting.
Oh yeah, the ferries start again, so there needs to be a wharf there.
To make a parallel between the amount of delay days and like the challenges you're going to experience. So well, you and speaking to Mike, but we've experienced 250 down days.
Yeah.
Since the feeding project.
Yeah. So
you did say that it's way more sheltered in the.
yeah.
Yeah. No,
Yeah, so obviously just been working with Gabby at Seaview and Matt as centre port, and we do experience a lot of delay with weather events, sea state, floating barges, and it's very difficult to plan. We have got the benefit that we don't need to work around fuel ships. But we do need to tackle the weather at the same time. So although the southerlies, we're sheltered in there up north of the island, it's actually the northerlies that get us. So
You've still got to get out there as well.
yeah, and get out there. Yeah.
They took some
Yeah, is there a backup plan if you guys get stuck there? You stay the night.
There is accommodation on the island.
Okay, nice.
So,
and the security officers, like, what kind of level of detail do they kind of look for? Are they kind of patting you down and checking your lunch boxes? Yeah, really.
Yep. So every morning we check our bags, check our lunch boxes, check everything. One of the biggest concerns that they are concerned about is an Argentinian ant, which they're known around Petone and the Lower Hutt area, and yeah, they don't want these ants getting on the island, so we need to pat down, check our pockets, check everything.
Is there a special dog as well?
Yep.
The dog was there.
Yeah.
Yep.
There is a special dog.
Yep. So our precast yard actually has these ants, so we need to get that all sprayed down, everything.
Thanks, Kyle.
Thanks.
Thanks all for that. That was really interesting. I was just going to try and cross over to Auckland and we'll meet Alex up there in the Becker office. So if you can hear me, Alex, jump on.
Hi, hello. Hopefully you can now see me and you can hear me. I'm going to quickly share my screen, and what I'm aiming to do is just to grab a little bit of feedback from people, so you can join on your phone and it works, you know, whether you're in the Wellington office, whether you're in the Christchurch office, whether you're in your house, or whether you're here in Auckland. You can scan the QR code, or you can go to the website and enter the code. We're just going to run through a little bit of feedback on the events, because these events are fantastic. We deliver lots of information, but one thing we'd like to improve on is trying to receive information so that we can better provide PIANC for for people who need it and use it. So I'll just give everyone a quick minute or two to get on. I think the people in Auckland are on. I'm looking on the corner in Wellington. I think a lot of people are on, but I'll still give you a little bit more time. And I'll try and get through these relatively quickly so we can all get home. And whilst it's already dark, but before it's darker, will be nice. I've got a few thumbs up. I think everyone in the Auckland office is here. Wellington, I started to look at little boards. So I'm assuming they're online. So we're going to move to the first question. So Andy did run through this one, just a little bit of engagement. What does PIANC stand for? And as you answer the question, the numbers of responses will pop up across the screen.
Alex, I can't see anything on your screen. Are you sharing something?
Yeah, I'm sharing my screen. Have I not been given permissions to share?
I have given you permissions. I can't see anything online.
On the far right screen, we've got what does PIANC stand for? The question.
Yeah, I can't see that online. I've joined online and I can't see that.
Join. Okay, let me give it another whirl.
It was showing that on my online.
I've just taken it off
Yep.
now. Brought
Can
it
see it
back.
now. Perfect.
Yeah. Beautiful. Okay.
Lots of happy people. Look at those thumbs up.
You can't ask ChatGPT.
So if you missed it online, the code is on the top, so you can go to the website menti.com and put in the code. It'll bring you to be part of the session. Okay, so we have 17 people. The thing is the Permanent International Associations of Navigation Congress. I actually can't remember what it is. I made this quite a while ago, but I think it's the second one. Andy might correct me. But yeah, moving on to the next question, if it will come up for me. Are you a PIANC member? Are you currently a PIANC member? That can count if you're, I won't give it you if your company's a corporate member and you're not an individual member. I want to gauge individuals.
Oh, we got some recruiting too. Look at that. That's good.
Okay, a lot of no's. Relative split, but maybe by the end of tomorrow we'll have, if I run it again, I'll have more yeses because people really enjoyed this session. Okay, moving on to the next one. What do you want to get out of PIANC? So this should allow you to type a response, and you can type as many responses as you want, and they will just flash up on screen as people submit them. Good times. I imagine that was Jono.
Melbourne.
There still seems to be one or two more responses rolling in. Give you a little bit more time on that one. And we are able to pull these responses out, and then in our next PIANC meeting, we can look at all the responses and see, how it relates. Have a mustache like Alex. Just only takes about 2 months. You just got to be patient and not trim it. Okay, 33 responses. I'll keep it pushing over to the next one. So we've got. No, that's not the one I wanted. That's the old event. So event feedback. So strongly agree on the left, strongly disagree on the left, strongly agree on the right. So whether this, for this event was worthwhile, whether you like the format of having speakers and presentations, and whether the actual topics are of interest to you. So for those who were at our previous event, you will know that the format was a little bit different as we had speakers across 3 locations, and this one was a contractor focus for Wellington, and then we'll move along to other locations and have the speakers focus there and have the watching parties elsewhere. 29 responses, getting looking quite well. Moving on to the next one, future event topics would you like? So, we are international waterborne transport, but this does include, as Andy mentioned, maritime, inland, recreational, environmental. So if there's other topics you want to see from us, please let us know, whether it's, more things on temporary works, things on sedimentation, whether it's things on future fuels, things on, the wind farm industry in New Zealand, so on and so forth. Completed projects that haven't yet started, IREX as always. Penguins and other friends, I would attend that event. But it'd have to be in person around what, May to July, and give a little net and I can catch them. Fishing, yeah, not bad, not bad. Vacuum fenders, I would like to know more about vacuum fenders and magnetic fender and the magnetic mooring myself. 28 responses, 19 people. Okay, we'll move on to the next one. And what event types do you actually want to see from PIANC? So what do you want us to provide yourselves? What do you feel like you'd get the benefit from us delivering?
Yeah. So lots of site visits.
Lots of site visits. Okay.
Ping out where below.
It seems to be a meeting.
Yeah, exactly.
A little bit of a clear winner, whereas the other three are, you know, sort of sitting in around each other, but lots of site visits. So I imagine we have lots of consultants in the room. Okay, it's 31 responses, and that's the end of our presentation and the end of the feedback session. Thank you for, you know, sticking with us to the end and actually listening to me at the final bit waffle on about trying to get some feedback. And I imagine if there's any closing words, they will be delivered by the team down there in Wellington. So yeah, thank you to everyone in Auckland who's joined, everyone in Wellington who's joined, those in Christchurch, those online, and whoever said they like my mustache. Yeah, big fan.